Two. Hello, everyone, and welcome to our Preparing for the PAT webinar. My name is Kat, my pronouns are she, her, and I am the Physics Access Officer at Oxford University, which means I run most of our programs which support young people who are hoping to study physics, either here in Oxford or at other competitive universities. This session is being recorded and will be made available to you tomorrow. Reminder of the housekeeping rules for those of you joining us on Zoom, which we hope is everyone this evening. You will be able to use the Q&A for any questions that you have tonight, and you'll be able to use our chat as well. Please keep it polite, keep it kind, and do not share any personal details or information. If you have any specific questions, pop those in the Q&A rather than the chat so that they don't get lost. But without further ado, let's get started. So first of all, let's find out what we are here for today. We are being joined on our PAT course this evening by Dr. Justin Palfreyman, and he will be able to tell you exactly what his role is. I'm going to run through very quickly what we are here for. Some of you will already know this. If you do, have a cup of tea. You don't need to listen to me. I'll give you a shout when it's time to come back. For everyone who is new, I will not take questions in this section, but you'll have plenty times later. First things first, the PAT is the physics admissions test at Oxford University. It must be sat by all candidates for physics, physics and philosophy, engineering and materials science. Your result on the PAT forms part of the information which admissions tutors use to decide who to shortlist for interview. To sit the PAT, you must register yourself as a candidate. Your school will not do this for you. The PAT this year will be on screen and entirely multiple choice. There will be roughly 40 questions with a total of 100 marks. And we've worked really hard to make sure that we can gain as much information as possible from this format. So the questions are not going to be 1 or 0. The online test includes a built-in on-screen calculator, which looks exactly like a regular calculator and works in just the same way. You'll do your working in an erasable booklet, which cannot be removed from the exam centre. The PAT syllabus is online, and it is your responsibility to ensure that you have covered it, either by self-study or through your studies so far. So that is the PAT course. That is the PAT. What about the PAT prep course? So the PAT prep course is what you are on today. It is a series of 8 webinars where we hope to provide you with all the information that you need to feel ready to sit the PAT. Along the way, we also try to make sure you've got enough confidence for your next stages, and we always provide a timetable. Our timetable on screen at the moment is at the bottom of every PAT email, and you can see we are on Study Focus 4. Our previous study focuses have been general problem solving, optics and waves, and study techniques and exam techniques for multiple choice. It's our 7th webinar, and I'll be sharing problem set 4 after this session. All of our materials are available to you, and you can find them on our course materials page. You can see at the top we have an introduction to physics problem solving, which includes some of the techniques shared in our first study focus and some of the techniques we'll be covering this evening. Underneath, you can access all of our recordings and all of our problems, and that is updated after every session and labelled so that you can jump in at any point. If this is your first webinar, welcome. You can go back and watch the previous 6 at your own speed. Some quick key facts for you. Oh, my apologies. It is week 7, not week 6. This is the most up-to-date page, and this is the one that you should bookmark and check throughout your preparation for the PAT. It has the syllabus on it if you need to find it. It has the link to register for the PAT that I've already told you about, and it has an excellent FAQ page that covers pretty much everything we've been asked. Some key facts, all of those tests this year will be sat at Pearson Test Centres. These venues are in almost every country around the world, and when you register, you will be able to select a centre which is most convenient for you. For some people, this may involve some travel, hopefully not too much. This arrangement is different to previous years, but it is exactly the same as the setup for tests like the LNAT, the BMAT, and the Cambridge admissions tests this year will also be sat at those test centres. Registration for the PAT is open, and it is open until the 4th of October. When you register for a test centre, you can when you register, you can select your test centre and you can apply for access arrangements. It is free to register for the PAT. You must apply for access arrangements when you register for the test. You can't go back and do that afterwards. And the PAT is the 28th of October, which for most UK students will be on a half-term day. It is a Monday. The test format that I mentioned earlier is a new one, but it's not as big a change as it seems. The questions are going to be really similar, and that syllabus is unchanged. It's been the same since 2018. Even though it's not a big change, we don't want anyone feeling anxious, and so you can access a trial version of the test. You can see what it looks like. You can use the calculator, and solutions are also available for that now. That is my super quick PAT introduction and update. I hope it was helpful. I'm going to stop sharing and hand over to our lovely Dr. Justin Palfreyman, who will introduce himself, take you through today's session. I'm going to sit in the background and man your chat for you, Justin. Hello.
Hello, thank you very much for that. I've just noticed that we do have at least one of my students in here, so I need to be very careful about what I actually say about my
Hey,
day job.
welcome to Justin's physics students from school. Lovely.
Yes, so I'm currently teaching in North London. Been teaching sixth form, I think, about 11 years now. Ambassador for Isaac Physics, and I helped with the conception of this course. And I've just got lots and lots of fun problems.
Excellent. That's what we want to hear.
So we're going to go through about 10 problems today. If we go quickly, I've got some bonus problems lined up, but you won't have seen those already. And we'll probably spend about 5 minutes, and I'm going to drip feed you some clues. So these might be different problems to what you would expect. You're not really going to get problems like this in the PAT itself, but behind each one, there's a message. So we'll solve them and then we'll see what that message is. And hopefully it's going to help you to improve your problem solving technique. Okay. So in the chat, not to everybody, please just select host and panelist. When you have an answer, you can type it in and I will give you a shout out if you're correct. And if you're working from the booklet, you can move on and make a head start on the next question.
Okay, I have just shared the link to the booklet in the chat, so everyone can click on that and follow through as well. So you can both see the questions on screen with Justin and work through them at your own speed.
Okay, and I'm probably going to shout at people who don't include units. So please, that's one of my bugbears. Please make sure you include units in your answers. Otherwise, I'm just going to make up a random unit and think that you're crazy. So without further ado, here is the first problem. Looks like a standard maths problem, really. You've got a rectangle, ABCD, which has a total area of 120 centimeters squared. And inside it, we have a blue shaded area. What is the area of the shaded part, please? Okay, I think Catherine, the question from Sophia is not one that I can answer.
Don't worry, Justin, I'm answering it right now.
Lovely.
We've only got one answer for the area so far, though, Justin.
Alan, you may move on. And with units, Ismail, move on.
I think they took your warning seriously to include units.
Yes. Our first wrong answer. Harris, it is larger. Yes, Sophia. Emma, it's larger than that. Oh, sorry, Sophie. And Emma, please put your next answer just to the hosts and panelists. Daniel and Toby, you are correct. Ryan, you're also correct. As is Harris. Second time's a charm. Okay, I'm going to start dropping you some hints. When I first came across this problem, it was because it was set to some primary school kids in Singapore. And this is the kind of problems that they do for breakfast. Emma, larger, please. Perhaps drawing some lines on the diagram may be useful for you. Don't give me the answers to question 2 just yet. But if you think you're confident, just keep moving on through the booklet. Normally those lines result in a flood of correct answers. You know that's correct. The booklet link was sent at 6:38, I think. If you scroll through the chat to then.
Yep, I've just reposted it as well in case nobody can find it.
Okay. Oh, this looks like a Russian name, which I've got no chance of pronouncing, but it's larger. Correct, Toby. Okay, so I think we've got enough people getting the right answer here. So you'll notice with these shapes that I've drawn, lots of people saying 52. Seems to be quite a common wrong answer. So with these lines I've drawn, I've actually made myself 4 sections where it's a 50-50 split between the shaded area and the white area, which is useful. If I can work out this area in the middle, well, this is a rectangle of length 8 and height 2. So that's got an area of 16 centimeters. If I take that away from the 120 to give me 104 centimeters, I can now see that half of that, which is where that 52 is coming from, I guess. So that 52 centimeters is these other blue sections. Don't forget to add back in that 16 that we had. And when you do that, you'll get your 68 centimeters squared. Quite a few people coming in with that answer now. Okay, good to see. So I think the learning point from this is draw lines on your diagrams. And it's amazing how useful diagrams can be. Without those lines, this is a very tricky problem. Okay, question 2. I expect a few answers coming in because people have been looking at this for a few minutes now. Units, Orion. I told you this would happen. Okay, Alan. The obvious wrong answer. Harris correct. Orion, you've added units, but you've changed your number. Okay, Orion, that's correct. Sanj Bhatti, correct. And I hope you're doing this without a calculator. Toby, you've fallen for the wrong answer. Daniel, it's a nice number. Okay, Faris, I'm not sure how it could be slower in the second scenario. So just reiterating what's going on here. You've got a ball that is initially at rest at the top of a hill. Everything's frictionless. You give it a tiny little nudge. And when it gets to the bottom of the hill, it's traveling at 4 meters per second. Now we think about what if I were to push it and give it an initial velocity at 3 meters per second at the top of the hill? What would be its new final velocity? Okay, Joseph, you are correct, as is Sophie and Alan. Irish name. I can't pronounce it, but I'm going with tag. No, it's less than that. Alice, correct. Jacob's correct. Faris is correct. Tariq, why are you working out the height? That's not the question. The height's irrelevant. The height can be anything. Well, could it be anything? Maybe not, actually. But I'm not interested in the height. Damien, you're correct. Toby, you're correct, as is Aaron. Tabitha, too high. Robert, units. Ari, units. Robert's correct. Gabriel's correct. Okay, nice and easy one by the look of it. It's a nice number. Dory, what are you doing? Okay, so it's just a conservation of energy. People generally get confused because we don't give them the height. How can I possibly work things out without the height? I'm not giving you the mass either. But the mass, we know, we're used to that. The mass always cancels out. Turns out the height, we can, kind of substitute for it anyway. So just looking at the table, that's our initial condition for the first scenario, purely gravitational potential energy, and then it ends just with kinetic energy. Now, in the second scenario, it's got the gravitational potential, but we're also giving it a kick. And at the end, that's all turned into kinetic. So we can make these two equal to each other. How do we deal with the height? Well, we know from the first scenario that mgh is just going to be half mv squared. So when we substitute for that in, we then hopefully recognize that we have a lovely Pythagorean triple of 3 squared plus 4 squared will give us 5 squared, and everything else cancels out. So no need for a calculator for that. Okay, well done if you got that. A few others just beating me to the answer. Oh, someone on question 3 already. Sanj Bhatti, too big. Okay, so in question 3, I have 1,000 cubes, and I've put them all together to make 1 mega cube. And my question is, how many of those 1,000 cubes are on the outside? Okay, Robert, more than that. Orion, you may move on, as may Danielle, Harris, Joseph, and Alan, and Gabriel. Lots of people getting this correct. Certainly less than 1,000. Steph, it's more than that. George, I know what you've done wrong. You've counted the corners 3 times and the edges twice. Okay, Damien, correct tag. It's higher. Now, the question is, those people who have got it correct, did you do it the efficient way? Or did you do it the long, tedious way? Because with most of these, there's going to be an easy way and a hard way to solve them. Okay. So Ari is correct. Leon, too big. Shia, too small. Dory, too big. Yes, Orion, that's the key to it. Irini, too big. Michael, too small. Brooklyn, too big. Theo, correct. Elias, too big. Alice and Robert are correct. Okay, thank you, Daniel, for giving me your working. Yeah, lots of us doing it the quick way. James, you're too big. Ismail's correct. Matthew's too small. Venetia, too big. Toby's correct. Okay, so let's start dropping some hints here. The key thing here, and quite often you do this with probability calculations, is you ask the opposite question because it's often easier to find that out. So instead of asking how many are on the outside, how many are on the inside? And then you can just subtract that from the 1,000. So if you strip off a layer on each side, you're going to be left with an 8 by 8 by 8 cube. Okay, which is, of course, 512 individual cubes. So subtracting that from your 1,000 gives you 488. Okay. So question 4, I'll just read it for you. So you have a bartender who pours 100 milliliters of tonic water into one glass and 100 milliliters of gin into another. This is going to be quite strong. We take a 30 ml shot glass and we scoop a shot of gin and pour it into the tonic, give it a good old mix. And now we take the shot glass and we transfer 30 ml of the mixture back into the gin glass. So is there more tonic in the gin or more gin in the tonic? Wow, 53 messages to get through. Da, 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 da. Okay, Harris, yes, you are correct. As is Han. Okay, I'm just going to try and read out the correct answers if I can. Una. Damien. Orion. Okay, if you answered more than a minute ago, I might have missed you. Need to make this chat a bit bigger. Okay, I think I've got everybody who's given me a correct answer so far. Gabriel, yes. Tabitha, yes. Michael, yes. Okay. So this is kind of a counterintuitive question. So Alice says more gin in the tonic because the gin you take out of the tonic is more diluted, which is obviously true. But many of you have spotted that there is a secret third option, that it is the same. So how can we visualize this clearly? Rather than think about, liquids, because liquids are a little bit messy, maybe think about marbles. You've got 100 blue marbles and 100 red marbles in these different containers or glasses. If I move 30 red into the blue and I give it a bit of a mix, and then I move 30 of those mix back into the red, well, the total number of marbles that I'm going to have in each container will still be 100. So however many red ones are missing because they're in the blue, they must have been replaced by an equal number of blue ones from the other container. Okay, so that's kind of the quicker way of thinking about it. If you do the math, you can do the math, that is possible. Then you will discover that it is the same and you can work out the exact ratio, but that wasn't important. Okay, so think about it from kind of a non-mathematical way, a starting point versus an end point, and maybe model it as something a little bit more easy to model. Okay, on to question 5. We've got our first correct answer come in already. So I'll just skip on to that. So we've got a race with 2024 entrants, and they're all numbered randomly from 1 to 2024. What is the probability that the first 3 runners to cross the finish line are numbered in ascending order? Doesn't have to be consecutive, just in ascending order. Okay, so we've got Robert, Harris, Damien, and Orion giving me the correct answer. Manus, no. I will be taking the answer as a fraction. It's quite a nice fraction it works out to be. Dylan, no. Tariq, no. Faris, no. Matthew, yes. Steph, no. Anna, yes. Toby, no. Alexandra, yes. George, no. Faris, no. Shia, no. Okay, the most common wrong answer seems to be an eighth. There's not 1/8. Tarini, yes. Gabriel, yes. Una, yes. So when I did this last year, we only had 2023 entrants, and the answer was the same. Okay, Zach, wait until I get there, please. But yes. Sophie and Jacob, yes. Okay, so I think we've got plenty of us, Tabitha and Aisha as well, coming to it with the correct answer. As long as there's more than 3 runners, it doesn't actually matter. Or well, even if there's just 3 runners, the answer is the same. So the way that we can think about this is you just take those first 3 runners and just label them A, B, and C. And there's only 6 possible permutations for the way that they could have crossed the finish line. Okay, so there they are. Okay, and each of them could be equally likely because, they're numbered at random. So when we assign numbers to A, B, and C, only one of these is going to have those numbers in ascending order. Okay, so it's a 1 in 6 chance for that one. So next question, we're blasting through this. I think I might get onto some bonus questions, but there's some of them will get a bit harder as we go through. So we've got an ant at the corner of a cube, which has a side length of A, and we want to travel to the opposite corner. And we're doing so by walking along the outside of the cube. So what is the minimum distance along the outside of the cube from one corner to the next? Yuna's in with the right answer, as is Orion. Toby, no. Tariq, no. Harris, yes. Gabriel, yes. Alan, no. A couple of people with this answer, Alan. But it's wrong. Gabriel, yes. Robert, yes. Zach, yes. Apologies. Manus, no. Russian sounding name, I think. Yes. Alice, yes. Emily, no. Oh, hang on. Sorry. Alice, no. What was I thinking? I had too much faith in you. Theo, no. Damien, no. Rahil, no. Isaac, no. Ellie, no. Tag, no. A meter? Where are you getting a meter from? I'm not giving you any units. Matthew, yes. Ismail, no. Elizabeth, no. Anne, yes. Toby, no. Sam, yes. Oh, another Toby. Toby S, no. In fact, both Tobys, no. Daniel, no. Michael, yes. George, no. Toby B. Oh, loads of Tobys. Toby B, yes. Ian, no. Alice, no. Ooh, okay. I think I need to drop a hint. Quite a few people, after we had a flood of people getting it right, including Ari and Alvira. Tariq's got it now. Rose, close, but no. So the key thing is the quickest path is a straight line. So how do you draw a straight line in 3 dimensions? Well, you turn the cube into a net and you identify those opposite corners. Okay, so dots, yes. Anyone else I missed? Rohill, yes. Rose, yes. Tina, Sophie, correct. Answers flooding in now. I think we're basically getting it. Yes, Tariq, Alexandra, looks good. So we draw our line. So those are the opposite corners. And then we just apply Pythagoras. Okay. So if we weren't getting the right answer, I suggest it's probably because you weren't drawing this diagram correctly. So, I mean, diagrams is quite a big message, but also thinking about, going 3D across these surfaces. So I think a lot of people might have been doing a diagonal and then just adding that 1 on. So I saw that answer quite a lot. Okay, but you can beat it and have an optimum length. Okay, let's move on. Oh, this problem should take us a while. I will be very impressed if people get this quickly. So the problem is that my field is overgrown and I am not going to invest in a tractor because they're expensive and they run on diesel, which is bad for the environment. And well, I mean, you can argue cows are bad for the environment as well, but the price is extortionate. However, I have a farmer friend who is trying to get more money out of his cows rather than just milking them. Because nowadays, so many people are going for soy and almond and all these other types of milk. What's wrong with cow's milk? Some people are lactose intolerant. Fine. So he's renting out his cows, basically. So I say, that's great. Give me 6 of your cows, and they're going to uniformly graze my field. And after 4 days, the grass is down to an acceptable level. And I think, yes, that's great. I'm very happy. The following year, my grass is overgrown again. Who would have thunk it? So I go to my mate and I say, can I have some of your cows, please? And it's like, well, business is booming, but I can give you 3 cows. I'm like, great, I'll take those 3 cows. This time, after spending 9 days grazing uniformly all around my field, the grass is down to the acceptable level. Lovely stuff. I have a little celebration. The following year, I'm in the same situation, but only 1 cow is available. And I'm thinking, lots of people, we're getting into party season. I might need to pre-book my marquee to have a big celebratory party. But I need to know when I'm going to book it for. So how many days will it take for 1 cow to graze my field to get it down to the level that I'm happy with? Tricky question. Okay, let's see. Dylan's first in with an attempt. It's longer than that. Same answer from Joseph and Leon. This seems to be quite a popular answer. No, it's more than that. It's going to be a whole number of days, by the way. You should get a nice, lovely integer number of days. Zach, it is longer. Aaron, longer. Uh, Emily, Tabitha, Faris, that's 6 people saying the same thing. Anna, well done. Move on. Very well done. Venetia, it's longer. Orion, longer. Ooh, somebody £9 GA2. I mean, I can actually read this one. But that's a very strange name if that is your real name. It's longer. Okay. Steph, Tarini, Sam, Brooklyn, longer. Venetia, longer. Daniel, longer. How could it be 2 days? 2 days it just doesn't make sense. Okay, Robert, longer. So many people saying 30. Why are we saying 30? What's the pattern that you think you've spotted? It's more than 30 days. I'll tell everybody that for free. Well done, Toby B. Well, I'm not sure why there's a question mark. When you get it, you should know that you've got it right. All these other people with their confident answers, but not quite wrong. So why is it non-linear? Surely 3 cows should take 8 days. Why not? What is going on? Tariq, you're quite close. Damien, you are spot on. Okay. Joseph, you weren't listening when I said it was more than 30 days. Okay. James, Aisha, Faris, Robert, you're all too low. Han, well done. Anyone in the chat who's not got the correct answer want to try to answer this first question? Why is it not non-linear? Maybe you can help us all out. If you can figure out why it's non-linear, that's a good starting point. Emily, you're correct. Geometric. Ah, yes, Robert and James. The grass is growing. That is why I have a problem in the first place, because grass keeps on growing. So the next step is to work out the daily growth rate. Meg, you've answered to everybody. James, it's longer. Aaron, I've already said it's more than 30 days. Well done, Sam. Ali, first person who's got an overestimate. Everyone else has been under so far, including Dory. Okay, ooh, second overestimate from Elsin. Okay, sometimes a clever use of units will help you to solve problems. So a nice unit to work in here is a cow day. So you may have heard of the unit man hours, which is like an amount of work. You know, it takes like 5 people 4 hours to paint a house. So that's the job is 20 man hours worth of um, work. However, a cow day represents a volume of grass. Michael, it's more. Oh, I coughed and revealed a clue. Overestimates from Venetia and Faris. Well done, Alan. Again, another question mark when you've got the answer right. I'm confused. So each year, uh, interesting question, Theo. Does the rate of growth per day equal the initial height? No. So we also need to work out the initial height. Um, so we can see that in year one, there's 24 cow days worth of grass that's been eaten. And in year two, 27 cow days worth of grass has been eaten. So that's a difference of 3 cow days. So an extra 3 cow days of grass has grown in 5 days. So the growth rate is clearly 3/5 of a cow day per day. But you can't cancel out the days. It's not 3/5 of the cow. Okay, so don't get confused by that. So we've now worked out the growth rate, which is nice because if it was more than 1 cow day per day, I would never get the field down to an acceptable level. Okay, Tariq is now in and confident. Good, well done, Tariq. Toby and Faris, it's higher still. Rose, it's higher. Yes, Toby S. Shia higher. Elias higher. Okay, so we need to work out how much grass there is at the start. And now we can work out the progress that 1 cow can make. So if a cow can eat 1 cow day per day, by definition, and it's growing at 3/5 of a cow day per day, well, then the cow can make progress at a rate of 2/5 of a cow day per day. So if I know how much there is at the start, then it becomes a very straightforward problem. Hang on, has Toby changed his mind? What am I looking at? Oh, yeah, so he put in a couple of answers. Rose more, Brooklyn more, Venetia more, Daniel more, Robert less, George correct. Okay, just a couple of boxes to go. Not got long to beat me to it. James, Zach. James has corrected himself, or is this a different James? Keeps moving so quickly. Let's just do the reveal at this point. Okay. But James D is in with the correct answer. As is Theo and Robert, just getting there quickly. The answer, Alice, so close, 54 days. Okay, so initially there's 21.6 cows days worth of grass, which we can work out from either year. So in year one, you've got 24, and then you minus 4 days of growth. Or in year two, you've got 27, and you minus 9 days of growth to give you what there was initially. Okay. So a lovely problem about modeling, kind of thinking outside the box. And lots of people approach this by trying to find some pattern with the maths and the numbers. And we had somebody mention a geometric progression or series, perhaps. No, think about the physics. Yeah, you expect it to be 8. Why is it not 8? What else haven't we thought about? Okay, so think about the problem in there as well. And think about units. What would be a useful unit and what does it represent physically? Okay, let's move on to this question about Sarah Connor and Kyle. So, what's happening in this situation? Essentially, we're living off grid because we're scared of being caught by the Terminators. And Sarah has a little house here with no water, and it's 3 kilometers away from a piranha infested river. In case anybody wanted to jump in the river and swim for any part of this, that's not going to happen. And Kyle lives 2 kilometers perpendicularly away from the river, and they're separated by 12 kilometers, this horizontal distance. So because there's no running water, we've got to basically go take a bucket, go to the river and fill it up, and then go to the other house. Doing this on a daily basis, we do not want to travel further than is absolutely necessary. So, what is the shortest distance from Sarah's house to Kyle's house via the river? And I'm looking for a nice answer. You don't need a calculator for this. Don't give me any square roots. Give me a nice answer, please. And if you can do it without a calculator, even better. Yes, Alan. Okay, Alan, can you, and Steph, can you just type something in the chat to me to let me know that you did this the efficient way? Yes, Sophie. Yes, Alan, that's correct. Thinking like a physicist. Yes, Steph. Spotting the nice numbers that I'm giving you. Toby B is correct. This is Alice. And Oscar, lots of correct answers here. And our Russian sounding friend. Would you mind just telling me if you are actually from Russia or somewhere else? Ooh, Toby. That's the middle way of doing it. There's an even easier way. Dylan, yes. Sheer, I'm not playing around with square roots, and I think that's probably too small actually. That's not possible. Toby S, you've spotted the nice numbers. Yes, Emma. Oh, then people without units. Ah, okay. So Sophia. Okay, so a few people spotting the similar triangles method in there. Rose is correct, and Rahil. Other people are surely Ari. That's got to be a typo. Okay, Orion, yes. Units, people. You know who you are. Zach, thank you. Okay, so if you give this to a mathematician, one of the things that they might want to do is go, this is a minimization problem. So I'm going to write myself an equation and I'm going to call this distance, say, x, and then this other distance, 12 minus x, and this distance I can use Pythagoras, this distance I can use Pythagoras, I can add them together, and then I can differentiate with respect to x. And if I do that twice, I can try to find a minimum or prove a minimum. But that gets a little bit nasty. So that's kind of like the mathematician's way of doing this. You can do it kind of trial and error, but how will you know that you've got exactly the right distance? Robert and Han, you are there with the correct distance. So what you might notice is the quickest way between 2 points, we've said this before, is a straight line. But how do we know that this is traveling in a straight line? Well, something that travels in a straight line is generally light. So let's imagine that I'm shining a laser beam and this is a mirror. So that would travel the shortest distance where the angle of incidence would equal the angle of reflection. And therefore these two angles, which are not the incidence and reflection, because that's from the normal, of course, but these two angles are the same. So now if we've got right angled triangles with angles the same, then these two triangles are also similar triangles. And lots of people spotted that we must have similar triangles in a 2:3 ratio. So therefore I can break down this 12 again into a 2:3 ratio, and then I can do Pythagoras. I don't need to do Pythagoras twice. I can do Pythagoras once on this one, then times it by 2.5, something like that, because of that ratio. That might be quicker. Or a couple of people spotted that we can just draw a straight line by thinking that if this is a mirror, where does the light appear to come from? Well, it appears to come from inside the mirror. So we can continue this as a straight line to this reflection. And now we have a right angled triangle of sides 5, 12, and thanks to Pythagoras, must be 13. Okay. So that is the quickest way of doing this. You might see these kind of problems if you're thinking about fiber optics, where you have many, many reflections and it gets very complicated. Rather than just think about these many, many reflections, just draw a straight line. And then you can work out kind of the path difference between the one that goes straight through the middle and the one that gets reflected, reflected the most. And that will give you your limit on bandwidth and modal dispersion and all those great things. Lovely stuff. Okay, this is also a technique when you start looking at university at kind of like charges and fields, because having a positive charge here has the same effect as if I had a negative charge reflected the other side of it. So yeah, you can find lots of applications where this could be quite useful for you. But the main thing is not just rushing in with the obvious way, which might well be for you guys the mathematician's way of trying to differentiate and stuff. You may think that you know too much. So take a step back. Is there another way, a simpler way that I can possibly solve this? And it can save you a lot of time in the end. Okay. Now, this one, we're traveling from Newcastle to Oxford by coach. Traffic is free flowing, and the coach's speed is only limited by whether the road is flat, in which case we can do 63 miles per hour. We're traveling uphill, in which case it's 56 miles per hour, or downhill, 72 miles per hour, technically over the speed limit, but generally you're allowed about 10% before you get a fine. And there don't happen to be any speed cameras, so he's fine with it. Anyway, the coach ride takes 4 hours from Newcastle to Oxford, but the return journey, which follows the same roads in reverse, takes an hour longer. How many miles is the coach ride between Newcastle and Oxford? And it looks like I've not given you enough information, but I have. Okay. Let's see who's going to get the gold star here. Dylan. Dylan, that is correct. Do you have access to the file with the solutions? It will be coming out. On Newcastle and Oxford at the same heights? Interesting question. I've not thought about it. I don't think you need to know. I don't think it matters. Zafia, that's quite close, but too high. Paris, that answer doesn't make sense. Even if I'm traveling all the way uphill, that means I'm doing 56 miles per hour for 4 hours. That surely sets a minimum that it could be. So you can easily find the minimum and the maximum. So 4 hours times 56 and times 72. It's somewhere within that range. Brooklyn, it's higher. Rose, close, but higher. Okay, Faris has suggested something that I think might be a clue. He spotted that, well, he said that all multiples of 9. 56, though? The other two are certainly multiples of 9, 63 and 72. I have carefully chosen these numbers to make it solvable. So there's something special about these numbers that makes it solvable. One, Tariq, that's outside the maximum range. Michael, woo! Yes. Anisha, too low. Okay, let's spot the first hint. So split it into three sections. Just consider a downhill bit for a distance of x, a flat bit for a distance of y, and then an uphill bit for a distance of z. And then map the return journey. And then you've just got GCSE physics, speed, distance, time. That's the only physics you need to apply here. Okay, Faris, sensible, but too low. Okay, Theo and James, you've given me ridiculous answers. Okay, so sense checking your answers is a key skill. I remember I mocked some exam papers several years ago, and the question was about the diameter of a neutron. And more than one person said that it was 6 meters, and they were happy with that. The neutron, 6 meters in diameter. Wow. Anyway, I digress. Sophie, yes, we're there. Anisha, sense check, please. We're after just the distance between Oxford and Newcastle, not a round trip distance. So that is way out of range. Faris, we're getting closer, but still too low. Okay. Let's reveal another hint. So this distance y, the flat distance, is the same both ways, but the x and z switch. So let's set ourselves up two simultaneous equations, but we've got three unknowns. Oh no. Doesn't matter. You can solve it. Look at those equations. Look at those numbers. What's special about those numbers that allows you to solve it? It's something to do with the fact that two of these are multiples of 9. So if you break them down into their factors, that could be useful for you. It's kind of a maths trick. But you need to know a bit of maths for your PAT. Okay, let's check that you've got the right equations. Let's get rid of those fractions. So in order to get rid of those fractions, Sam, there's no units on that. Why don't you just multiply them through by 504? Okay, Sam. Thank you for the units, but that answer doesn't make sense. At this point, I'm expecting a flood of correct answers. Why 504? Well, that's just 7 times 8 times 9. So these are your two equations. Yes, Sam, we got there. Yes, Ham. It's just math at this point. That's been math for a little while, to be honest. Yes, Sophia. Okay, 30 more seconds. Anyone else going to get in before the final line is revealed? Alice, we're there. Good. Okay. So the final line, all we do is we add them together, and that will give us 16, lots of x plus y plus z. And then there we go. 283.5. We're in miles, Leon, not kilometers. Thank you. Okay, a bit of rounding perhaps. Yeah, so that's an interesting one. A few things to think about. Set it up. Maybe drawing a diagram and labeling these sections would be quite helpful. And even when you don't think that mathematically you can answer it, maybe you can. Maybe there's a little trick in the numbers that have been given to you sometimes. Okay, so the last one that's in your booklet before we move on to the bonus questions. The age-old question, pirates versus ninjas. Who's going to win this battle to the death? So the ninja very stealthily is moving forwards at an average speed of 4 meters per second. They start off in this face-off 90 meters apart. The parrot, of course, is going to waddle with his peg leg. Pirate, I think I might have said parrot. We'll get to the parrot in a moment. So the pirate waddles with his peg leg at an average speed of 2 meters per second, but he has his animal companion, the parrot, who can fly at 8 meters per second. And he's looking at the ninja, seeing if he can spot any chink in his armor. And he rebounds elastically from the ninja back to the pirate. And when he gets to the pirate, he squawks in his ear with whatever information he's found out, and he rebounds elastically again, going backwards and forwards for more intel until eventually he gets crushed between the two. How far in total does the parrot fly before being crushed? This should be quite a straightforward question, actually. Lots of answers coming in. Strange units from Sophia. What have we got? Michael, Theo, and Matthew, and Dara, and Tariq. I know you know the answer to this. I've done it before. Sophie, okay. Sophia, yes. James, Han, yes. Alice, no, that can't make sense. Dot, James, Emma, Dylan, yes. I presume you're doing it the quick way with those quick answers. Brooklyn, Moore, Alexandra, Tabitha, yes. Toby B, no. It's not going to make sense, that Toby. He's going to travel further than that the first time he actually collides with the ninja. Zach, you're answering a different question. I'm after a distance. although that could be a key part of getting to the distance. Oscar, yes. And Rohill, yes. So let's not spend too much time on this. Ian, it's more. Faris, it's less. Sam and Zach and Venetia, you are correct. So you could take the mathematical approach and do an infinite sum, which will be fun. So the first time that they meet, the parrot will have traveled 60 meters because this guy's traveling half the speed. So the parrot must travel twice the distance to meet them. So he'll collide at 60 meters, and then you could work out where the pirate is, and then you could do the same thing. So he's traveling at 4 times the speed, so he'll travel, 4/5 of that remaining distance, and then we work out where the ninja's got to at that point, and then we just rinse and repeat, and we get smaller and smaller. This infinite geometric progression, perhaps. So that's one way that you could do it, but it is a long and a stupid way of doing it. Let's be honest. What have we got? Lots more right answers. Sanjibati and Tasia, Gabriel, Ian's now in with the correct answer. Harris, Ellie, and Toby S. You're all correct. Ari, you're too big. Might have missed some people there. So the key thing to realize is the parrot is traveling at a constant speed. So in order to work out the distance, if you've got a constant speed, all you need is the time. So how long does he fly for? Well, thinking about relative velocities here, the relative velocity between the ninja and the pirate is 6 meters per second. That's how far they're gaining every second. So how long is it going to take them to get 90 meters closer? Well, that's only going to be 15 seconds. So if I'm traveling for 15 seconds at 8 meters per second, because I'm elastically colliding, then it will be 120 meters. Okay, a few people in there at the end with the right answer. Changing the frame of reference. A frame of reference, yeah, that's a good idea as well. I don't know if you had this question in one of the earlier sessions about trams, walking down the road and being overtaken by some trams and then some other trams going the other way. And I get 15 one way and 20 the other way, and I need to work out my speed. The easy way to do that question is thinking about frames of reference. But yeah, in this case, frames of reference don't really help you that much. It's not a great advantage, but quite often can model them as waves. Yes, lovely stuff. Excellent. That's another one of my nice questions. I remember when this used to be live at Oxford, and the undergrad who was supposed to be helping out couldn't solve it, and then they looked at me because I wrote it. I'm like, I've completely forgotten how to solve it. You're going to have to give me 5 minutes. Eventually, it did come back to me, but it was a little embarrassing at the time. Okay, so on to some bonus questions. We've got about 12 minutes for these. Let's see if we can get through all four. So we're filling up a bathtub. If I run the hot water tap, it takes 20 minutes. The cold water tap takes 15. That's a little bit strange. Normally the cold water tap would be, oh no, that makes sense. The cold water tap's quicker. And if I drain the bath by removing the plug, it would take 10 minutes to drain the bath. But let's imagine that I run both taps at the same time and I leave the plug out. How long will it take to fill the bathtub? Correct, Alexandra. I'd say move on, but you don't know what the next question is. So you're just going to have to wait for not more than 3 minutes on this one. Yes, Orion. Harris, I am making the assumption that it's not pressure related. So yes, the drainage is linear. But I like the way you're thinking, like a real physicist. But we like to model things simply to start with, and then we can add in complexity later on. Venetia, it will take longer. Theo and Toby B, correct. Rohill and Tariq, correct. Theo's been thinking about the grass. That's an interesting way of thinking about it. There's probably an easier way of thinking about it. If you were given the question about Haley and Rob painting my house, that's the one that's most similar. Faris, it will take longer. Zach, Gabriel, Hans, Roberts, yes, that's correct. Oscar, longer. Units method. Sophie, Zofia. Oh no, Sophie, correct. Zofia, longer. Yes, lots and lots of people coming in with the right answer now. So this is a rate problem, just like painting my house, except here we have a negative thing. We've got something going away from it. So this is essentially adding resistors in parallel, because that's about rates of flow of current. In this case, this is just rates of flow of water. But unlike resistors, you won't get a negative resistance. Okay, but we can still use this, idea, this formula, and you can even do it in your head if you like, because the numbers work out quite nicely. So when you plug all of that in together, it's 1/60. So of course it must be 60 minutes or 1 hour for that one. Lovely stuff. Okay, now next one, I'm just going to say sorry. Find the altitude, which is labeled H, of the triangle that I've drawn below. A is 9 centimeters, B is 16, and C is 25. I've not drawn it to scale. Very good stuff. And Alice. Okay, Robert, there's no units. Come on. And you've also given me kind of a calculation to do rather than an answer. And it's wrong, let's be honest. There's so many things to say about that. Thank you for doing the calculation, Emma, but it is wrong. Alexandra, correct. Zach, I am going to insist on units. James, yes. Thank you, Zach. That is correct. No, Tariq, I am so going to roast you tomorrow about this. Yes, Roberts. Indeed, you spotted my trap. 9, 16, 25. Looks like a Pythagorean triple. 3 squared, 4 squared, 5 squared, yeah. I mean, it is helpful to know that 3 squared plus 4 squared equals 5 squared. Han, no. So a little hint for you. This could be solved by a primary school child, not necessarily of Singaporean origins, although I'm sure that they would find this very straightforward. Harris, yes. Theo, no. Harry, no. Lots of people coming across with 9 centimeters. 9 centimeters is incorrect. Oh, Sophie. I mean, technically, what is the definition of a triangle? Is it not just 3 lines that join together? That makes a triangle. Dots, no units. Well done, Alan and Ari. Rohill, no. Oh, you're so going to kick yourselves. Okay. The height is 0. Why? Because A plus B equals C. If you attempted to draw this, it would be obvious. Yeah, so draw yourself a 25 centimeter line, get a compass, set it to 9 centimeters, set it to 16 centimeters, draw it. Where do they meet? They meet here. Ah, we don't even need a compass because we can see that that is obvious. Okay, so the lesson here is about assumptions. You see these numbers, you think you recognize them. This looks like it could be a right angle, perhaps. I did tell you it's not drawn to scale. Okay, so question the assumptions that you might automatically make. A couple more questions. This one might be similar to something that you've done before, very recently, in fact. Okay, so a family exercises their dog in the following way. The parents sit on a beach while the children walk to a distant rock, calling to the dog as they walk. Parents and children alternately call the dog, who runs from one group to the other and back again. The children then walk back to their parents, still calling the dog on the way back. The dog travels at a constant speed. Where have I heard that before? And the children at a speed VC, which is less than VD, the speed of the dog. Calculate how far the dog runs in total when the distance from the parents to the rock is big D. So I'm looking for an expression, an algebraic expression for the total distance that the dog travels. Okay. Okay, Sam, I'm going to have to think about what your question means because I'm a bit tired. Alexandra, that is what I've written down. Yes. We don't need units when it's just an algebraic expression. Units only really make sense when there's numbers involved. Faris, no. Alan, oh, it's going so quickly. Let's see if I can just pick out the right answers for you. Alan, yes. Oh, Ellie, close. Matthew, yes. Tabitha, yes. Toby, S is correct. Tariq, a bit of redemption for you. Tag, correct. Okay, Sam. Okay, Sam. What you're doing may be valid, but is obviously a lot more complicated than just 9 plus 16 equals 25. So, yeah, the point of a lot of these is there's a hard way and there's an easy way. And the skill to being a good physicist is picking the easy way and having the experience of lots of different things in your tool chest. Brooklyn, yes. Rahil, yes. Alice, not quite the correct symbols, but essentially yes. Okay, lots of people coming in now. A few of us missed out the factor of 2 because it's a return journey. So the dog runs at constant speed for the time it takes the children to get to the rock and back. So that's what we need to work out. We need to work out the time it takes for the kids to get to the rock and back. Well, that's just distance divided by speed. The distance is 2d because we're going there and back, and that's their speed. So that's the time. We just multiply that by the speed of the dog, and lovely stuff. Okay, time for one final question. Only 2 minutes on this one. Nice probability question. We've got 3 cards hidden under a cloth on the table. We know that one card is white on both sides. One is black on both sides, and the other is black on one side and white on the other. I select a card at random, and its upper face is white. What's the odds that the other side is also white? Okay, I'm getting the obvious answer from the first 4, 5 people, 6 people, all giving me the same obvious wrong answer. Oh, we've got our first non-obvious wrong answer. Okay, so it is not a half, and it is not a sixth. We've got a few correct answers. Yeah, it's a given question. Thinking back to your probability, we're starting to get a few correct answers now. Okay, the last. Oh, we're getting. I've said it's not a half. Oh, a quarter. That's another wrong answer. A ninth and an 18th. 3 quarters is not correct. Okay. So there's a lot of people who are giving me one of 2 other answers. I'll reveal at the end which of those is correct. It is not 3/5. It's not an eighth. It's not 1. Okay, I think we are just about out of time now. So is it 1/3 or is it 2/3? It's one of those. Let's have a look. Think about it. Okay. So it's actually more likely that I have selected the white card, because half of the time the white-black card will have its black face up. So it will be impossible for me to have selected that card given that I'm saying that it's white. So obviously I can't have selected the black card. So we know it's between these 2 cards, the white card or the white-black card. But half of the time, the white-black card, it can't possibly be. Okay. So another way that you might think about this is to think about running the game twice. And we flip all of the cards the second time. Let's remove the cloth. So in total, there's only 3 white cards. And it's equally likely that I've selected any of those, given the information that I've been given. But of those 3 white cards, 2 of them are the white card. So therefore, it's a 2/3 chance that the other is also white. I like probability questions. Sometimes they're counterintuitive. So very well done. We had some very quick answers. We had good participation, lots and lots of incorrect answers, which I always like. And hopefully you've learnt some lessons and you can see the relevance to not just the PAT, but, you know, life and physics in general. I'm going to stop sharing there and hand back to Catherine.
Thank you so much, Justin. Thank you to everyone who got absolutely stuck in today. I hope you've enjoyed coming full circle and landing back at problem solving. And I hope the fact that we've landed at tricky problem solving has given you a few hints and tips about really paying attention to the questions and thinking about other things that you can do. So tomorrow I'm going to share the recording of this session so you can go back and you can watch it again. If you're joining us on that recording, I hope you enjoyed it. Sorry you weren't able to join in. And I will also share our final set of problems, problem set 4. Then next week is our final webinar. 2 of our undergraduates will be taking you through their solutions to problem set 4. We'll be joined by Helena from Materials Science. So if you have any last questions about admissions, hopefully Helena and I and our undergraduates will be able to answer them between us. Justin, is there anything else, any final tips you'd like to add before we sign off?
Draw a diagram.
Draw a diagram. I mean, yeah, solid tips. Draw a diagram. Think about if your numbers make sense. It made me laugh when you were saying about the neutron. I always like speeds greater than the speed of light.
Yeah,
Magnetic fields stronger than the inside of stars. They're a good thing to get
I've had
in
some
your head.
ridiculous answers. One of the most ridiculous answers for the speed of light was actually in a refraction thing, and the explanation was that the light slows down because the photons got tired.
Oh, poor little photons.
Yeah, poor little student who wrote that. Um, oh dear.
Amazing. Thank you so much. Thank you to everyone who's joined in, and we will see you next week. Thanks very much, guys. Bye for now.
Right.